Number 1, they want us to rewrite the equation in its equivalent exponential form. The base of that log is 14. That means it's going to be the base of our exponential equation. And then over here, doing the log on an argument gives us the exponent. So our exponent is going to be 2, and that's going to be equal to the argument that was given in the log form of the equation. So that is our equivalent exponential form. And number 2, they want us to express this as a single logarithm. First, I'm going to just check and see, do we have any numbers that are multiplying the front of that log that can become the exponents? Yes, we do. That 6 that's in front of that log can become the exponent on the y. And then I noticed that this log is negative, which means that part is going to be in the denominator when we express this as one log. So as one log, we have log base 5. X is going to be in the numerator because that log is positive, and our negative log argument y to the 6th is going to be in the denominator because that was negative. And so that is our expression re-expressed as a single log. And number 3, they want us to solve that equation. The first thing I want to do is try to isolate the base. So our base is 20, but there's this extra plus 4 being added on to the end. So first thing we want to do is get rid of it with a minus 4 to both sides. So those inverse operations are going to cancel, and we get 20m minus 9 equals, and then 77 minus 4, 73. Then what we could do is take the natural log on both sides of the equation. Anything we do to one side, we have to do to the other. And then what that allows us to do is actually use that power property and bring down the m minus 9 exponent. I'm going to put parentheses around it because that whole thing is in the exponent even though it has 2 parts. And that's multiplying our natural log of 20, and it's still equal to the natural log of 73. Now I want to start isolating our variable, which is m. Right now it's being multiplied by the natural log of 20, so we can divide by the natural log of 20. So that's going to cancel, and we get m minus 9 is equal to whatever the natural log of 73 over the natural log of 20 is. And then what we're going to want to do is add 9 to both sides in order to get m alone. So what we end up with is m equals, and then I'm going to put all that into my calculator, and I get m is 10.43. Then of course we would want to substitute that back into our equation just to check it and make sure that our solution is correct. Now number 4, the value of the property in a particular block follows a pattern of exponential growth. In the year 2001, your company purchased a piece of property in this block. The value of the property in thousands of dollars, t years after 2001, is given by the exponential growth model. According to the model, what is the property worth in the year 2010? So we do want to use this equation to find out the value of the property, and we need to figure out what value for t that we're going to plug into here. So if t is 2001, we want to do a little subtraction problem here. So 2010 minus 2001, that's going to give us t is 9. So let's plug that into our value equation. 500 times base e raised to the power of 0.055 times 9, and let's put that in the calculator, and we get 820.249. Now, referencing back into our problem, they said that's the value in thousands of dollars. So really I want to interpret this within the context of our problem. So we know we're dealing with money here. It's in thousands. I want to move the decimal place 3 times. $820,249. That's my answer for that question.